Let's work this question here. What we do have is an object of height 1 centimeter. Let's call it HO1. That is placed at a distance DO1 15 centimeters away from one lens, whose focal length is 10 centimeters. And first we need to find the position of the image, DI1. Okay, to do that we use the lens equation. 1 over f1 is going to be equal 1 over DO1 plus 1 over DI1. So 1 over DI1, that's what we are solving for, DI1, is going to be equal to 1 over f, I'm going to write it already, 1 over 10 centimeters, minus 1 over DO1, which is minus 1 over 15 centimeters. I'm going to use, since these are easy numbers, so I'm going to multiply this by 3 and that one by 2. Okay, so what we end up having, 1 over DI1 is going to be 3 minus 2 over 30 centimeters. So it is actually 1 over 30 centimeters, and that gives us our DI equal 30 centimeters. So this is my DI1. Now the next part is to find DO2. Since they give us the separation between both lenses here is 42 centimeters, so DO2 is going to be equal to L minus DI1. So in this case, it's going to be 42 minus 30 centimeters, or 12 centimeters. And now we'll solve for DI2. DI2, sorry, 1 over DI2 using the thin lens equation, it's going to be 1 over f minus 1 over DO2. F is given to us here as 5 centimeters, so that's going to be 1 over 5 centimeters minus 1 over 12 centimeters. Okay. Now, so we just have to solve for that. DI2 then is equal to 12 centimeters times 5 centimeters over 5 centimeters plus 12. Do your own algebra here. You don't have to stick to what I'm doing. No, actually, my apologies, this is totally wrong. So I'm going to put the same denominator again. So 1 over the I2 is equal 12 over 60 centimeters minus 5 over 60 centimeters. So it's going to be 7 over 60 centimeters, and my DI2 is just 60 over 7 centimeters, and that should be equal to 8.6 centimeters. Okay, that's my final DI. Now what about the magnification, or what's the size of the final image? Okay, to do that, I'm going to erase some of this. The magnification, remember, is going to be HI2, the final image height, over HO1. And that's going to be equal to the magnification due to lens 1 times the magnification due to lens 2. If I'm trying to find the height of the final image. So hi2 is going to be simply ho1 that we know that's given times m. So I need to find what m is. So to find m, m1 is minus di1 over do1. So in this case, that's going to be 30 centimeters with a minus sign over 15 centimeters. So it is equal to 2. Okay. Similarly, I calculate m2. m2 is equal to minus di2 over do2. di2 is what we said, 8.6 centimeters. By the way, I forgot the minus sign there. It's equal to minus 2, of course. So minus 8.6 over do, which is 12. Okay. So now my overall magnification is the product of these two. So it's going to be minus 2 times minus 8.6 over 12. Okay. So let me erase here. So my m is going to be 8.6 over 6. About 1.4, and then we find hi2, then it is 1 centimeter, ho1, number from here, 1 centimeter times 1.4, so we come up with 1.4 centimeters. Okay, wonderful. Now let's check this other problem here. I purposely didn't put the image, I just dumped these there. It's the same situation for the first lens, so we don't have to recalculate, we have the answers already, and this is 1 centimeter. So where are we going to find, so this is di1, this is do1, so this is do2, so where would the final image be if I have a divergent lens instead? We use the lens equation like we used last time. 1 over di2 is going to be equal to 1 over f minus 1 over do2, and in this case it's going to be minus, let me write it correctly, 1 over minus 5 centimeters minus 1 over 12 centimeters. I'm going to put it in the same denominator like last time, so that's going to be minus, so I'm multiplying this by 12, so minus 12 minus 5 over 60. So we get minus 17 over 60. And di2 then comes out to be minus 60 over 17, which is equal minus 3.5 centimeters. Now, the key here to the minus sign, it tells us that my image is actually in the same side as the object. So it's going to be less than 5 centimeters, so it's going to be somewhere here. That's where my image is. Okay, now let's find the magnification. We calculated the first magnification last time as m1 equals to 2, and the second magnification is going to be minus di over do, di2 over do2, of course, and in this case it's going to be minus 3.5 over do2, which is 12 centimeters, so that's a 0.29. So my overall magnification, M1 times M2, so 0.29 times 2, so it's going to come out to about 0.6 or 0.59, and then my image height, like what we did here, I forgot the minus sign here. Remember that M1 is minus 2, not 2. So my HI2 is going to be equal to the magnification, which is minus 0.59 times 1 centimeter. So it is minus 0.59 centimeters. The sign tells us that it is flipped, and you see that it is smaller than the object since it's 0.59.